Hello, this is the second video follow from the derivations of vector product, right? The formula for the vector product. So now I'm going to show you that how to using that methods in finding the cross product in an easier way. So let's say if I have vector A cross with vector B, so which is vector A, which is 2i, vector 2i plus with 3j negative 2k, vector A cross, this is cross product. So 4i minus with 2j plus with 3k, right? We cross this one. We can simplify just by using the determinant form, right? So I, j, k. So means we're going to use the concept of expanding of row, right? By using the determinant. So expanding, so means the expansion of the determinant, okay? And for more accurate, expansion of the determinants. So means that ijk, so the first row will be 2, right? Just now I have showing x1, just now in the video, previous video I showed x1, x2, y1, z1, right? So 2, 3, negative 2, okay? So 4, negative 2, 3. 4, negative 2, 3, x2, y2, z2. So I'm not going to expand one by one, right? As it's very time consuming, alright? That's why I taking so long to explain why I need to generate this formula here. So the easiest way will be this way, right? We look at the I just like expansion of the determinant. Do you still remember the sign of cofactor we used for the first row? So, and we have I, right? I, negative, negative, so j. So it's easy to think in this way. So and k, right? So what is the minor for I? We just like thinking like doing for determinant, right? So you delete the row, delete the column, right? So you have 3, negative 2, 3, negative 2, negative 2, 3. Alright, this is the way. This x, y, y2, z2, y1, z1, y2, z2, right? So now I know that I delete the row and column, I will getting 3, negative 2, negative 2, 3. For j, right, for j, so I delete the row, I delete the column, right? So I have 2, negative 2, 2, negative 2, 4, 3, right? Which is x1, z1, x2, z2. So and for k, right? For k, so I delete the row and the column, or the minor for k, which is 2, 3, 4, negative 2. 2, 3, 4, negative 2. Or we say x1, y1, x2, y2. Alright, so without thinking about, without doing the normal way of expanding, we're using this method here by using expansion of determinant. So we have 3, 3, we have 9, right? 3 times 3, we have 9. And negative with AD, alright? A, B, C, D. We're taking AD minus BC, just like finding determinant. 3 times 3, 9. Minus with negative 2 times negative 2, we have 4I, right? So 2 times 3, 6, right? 2 times 3, 6. So negative with 4 times with negative 2, 4 times with negative 2, we have negative 8, right? Negative 8. Negative 8 and negative become positive 8j, right? And lastly, we have positive 2 times negative 2, we have negative 4. Negative with minus with 4 times 3, we have 12k. This is a lot easier, right? So finally, we have 5i, right? 5i. So and this you have negative 14j, right? Negative 14j. Negative with 4 and 12, we have 16k, right? So this is the result of A cross B. Can you see that? We produce another vector. This is a vector, right? Means that two vector, when you do cross product, you produce another vector. Alright? So this is the way we're doing the cross product. So hope you understand how to doing the cross product. And later after this video, in this video, I'm going to explain what is the relationship between this vector that you produce here. Relationship between these two, vector A and vector B. Right? Let's listen to what I'm explaining. Alright, okay, if I want to prove to you that A cross B, what is the relation between A cross B and A? Right? In the first lessons, right, we have explained that let's say you have a vector A, right? Vector A, so cross with vector B, right? A cross with B, so I'm going counterclockwise. A cross with B, right? A cross with B, my thumbs go up, right? Go up, so means that so this will be your A cross B, right? Which the A cross B that you produce is actually the normal vector of A and B, of the plane that consists A and B. Means that the plane that consists vector A and produce B, when you're crossing, you're getting a normal vector, or we said a perpendicular, right, vector, which is perpendicular to B and also perpendicular to A. Alright? Or if you're taking B cross A, you will still getting another result, which is B cross A, right? B cross A, right? We're getting downwards. So, and these two are anti-direction, but they have the same magnitude. We have the same magnitude. Means that I can say that A cross B is the same as B cross A in terms of magnitude. Panjang dia, okay, magnitude. But when I said about direction, they are actually anti-direction to each other. Alright, A cross B is negative, B cross A. This is what we call is not commutative. Alright, not commutative. The meaning here means that for dot product, A dot B is the same as B dot A. The result will be the same. So why? They are commutative. This is not commutative. So, and one more important thing that I want to tell you is A cross B is perpendicular to B and A, right? Based on dot product, based on the result of dot product, if a vector A dot with B is equals to 0, right, is 0, it can tell you a result here. Means that the A is actually perpendicular to B, right? Okay, so I'm going to prove to you what is the relationship between A cross B and A. Alright, relationship between A cross B and A by using the number here. Alright, as I tell you that A cross B is perpendicular to B and A, so I have to show you, I have to prove to you. Alright, so if I taking A cross B, I go and dot with vector A, right? The vector A must be inside this bracket. So A cross B dot with A. Alright. So I try taking A cross B, which is 5, negative 4, negative 16. Alright. Negative 14, negative 16. Go and dot product with A, vector A, which is 2, 3, negative 2. So you have 10, negative 42 plus with 32. Right, so you have 42, 10 plus 32 minus with 42, you are getting 0. Can you see that? You're getting a 0, right? Not always you're getting a 0, because A cross B is perpendicular to A. Is perpendicular to A, and the result will be the same. If you're taking A cross B, go and dot with B. As long as this vector is inside the cross product, this vector is inside the cross product, you are getting a 0 vector. Alright. Sorry, you are getting a 0. So A cross B, which is 5, negative 14, negative 16. Dot with B. B 4, negative 2, 3. 4, negative 2, 3. So if you calculate 4 times 5, you have 20. Right? Negative, positive 28. So negative with 48, right? 16 times 3, 48. 20 plus 28, 48. Minus 48, you are still getting 0. This is a very important result here. Where A cross B dot with A, you're getting 0. A cross B dot with B getting 0. This shows that A cross B, this vector, this vector is actually perpendicular to B and also A. So I have using a specific way, alright, specific way to prove to you A cross B is actually perpendicular to A and B. So A cross B dot A, you're getting 0. A cross B dot B is equal to 0. So there's come another property. So when A cross B, if you dot with A, it will become 0 because vector A and vector A cross B is perpendicular to each other. And A cross B dot with B, you're also getting 0, right? So I have proved to you that this is true. Alright, so hope you understand about the concept here. Alright, the most important is the concept here. Alright, so we will go for more concept in the next video.